Okay, let's unpack this.
We are definitely diving deep today. This is a topic that isn't just changing an industry. I think it's fair to say it's redefining the entire creative process.
I agree. We're talking about how artificial intelligence is, well, it's becoming the engine room for the next era of video
It
games.
really is. And for this deep dive, that's our mission, to get into how generative AI and machine learning are moving so far beyond what we used to think of as AI.
Right, it's not just about, smarter enemies anymore.
Not at all. We're talking about creating dynamic content, truly personalized player experiences,
Yeah.
and entirely new types of game worlds, things that, frankly, were impossible before.
Exactly. For decades, the video game world was all about human-authored content. I mean, every single rock, every piece of terrain, every line of dialogue. A designer put it there for a reason.
It was all handcrafted.
Yeah.
But that's the big shift. The transformation we're seeing is immediate, and it is massive.
And the sources we've looked at make it clear this isn't some far-off future concept.
No, it's a strategic reality right now. The whole conversation inside major studios has completely flipped. It's gone from, so, should we maybe adopt some AI tools? To
How fast can we integrate this into every single part of our pipeline?
precisely. The urgency is palpable.
And you can see that urgency in the data. When you look at the industry landscape, I was floored by this number. 52% of developers are already working at companies that are using generative AI tools.
52%. That's the majority. It's not a niche experiment anymore.
It's the new standard for a huge chunk of the industry.
But I think the number that really shows the sheer pace of this change is about the output. It's what you, the player, are going to see.
Right. What's actually hitting the market?
If we look ahead to 2025, the projections show that nearly 1 in 5 new games released will include AI-generated assets in a significant way.
1 in 5. So this year, you're almost guaranteed to be playing in a world that was, at least in part, built by an AI.
And you'll feel that. You'll see these massive, incredibly complex, and varied worlds that didn't require that traditional huge jump in development time and cost.
It really underscores what a massive break this is from the past. I think when a lot of people hear AI in games, their minds still go to, a computer opponent in a chess game.
Or just slightly smarter bad guys. So we should probably trace that history just to set the stage for how big this leap really is.
Yeah, let's do that. Where does it all begin?
For decades, AI just meant highly predictable, rules-based systems. We started, historically, with really simple behavior in old arcade games.
You're talking about the ghosts in Pac-Man.
Exactly. Or the enemies in Space Invaders. They follow a fixed path, or they react the exact same way every single time. It's deterministic.
You learn the pattern, you win the game. Simple.
That simplicity eventually gave way to a really key architectural shift in the 90s and early 2000s, which was the finite state machine, or FSM.
Okay, so this was a critical step up.
A huge step. Instead of just one path, an NPC could now exist in different named states. Things like patrolling, or investigating a noise, or in combat. And they would transition between these states based on triggers the developer put in.
So, like the classic example, the guard in Half-Life, he's just walking his patrol route.
He's in the patrolling state.
Right. Then he hears a gunshot and he switches to alerted. And if he sees you, he goes into combat.
Exactly that. They felt so much smarter. But the key limitation was that every single one of those transitions had to be manually programmed. Every possibility.
And if the designer didn't think of something?
The AI would just fail. It would get stuck or do something weird. That's where you get all those classic funny AI glitches, because the AI couldn't handle a situation its creator hadn't explicitly planned for.
Okay, so that brings us to the next big leap in the 2010s. Behavior trees. These were the industry standard for a really long time.
And they were a big improvement. Behavior trees allowed for much more complex, hierarchical decision-making.
What does that mean in practice? How is it different from a state machine?
Well, think of it literally like a tree structure. It organizes actions into a series of priorities and checks. So an enemy AI might first check, is the player visible? If yes, it goes down the attack branch. If no, it checks, did I hear a noise? If yes, it goes down the investigate branch.
It's a much more complex logic flow.
A much deeper one. Games like Halo and The Last of Us use these to make enemies seem incredibly intelligent. They could perform coordinated tactics, take cover, flank you.
But, and this is the crucial point, right? Even these were still just hard-coded logic trees.
Still hard-coded. The intelligence was all simulated by how deep and clever the designer's manual scripting was. It was an illusion of intelligence, a very, very convincing one.
But one that took thousands and thousands of hours to create, which is the fundamental limitation we're finally starting to overcome.
And that brings us to today. The modern era, the 2020s, is defined by machine learning-driven AI. And this is a whole different ballgame.
Because these systems aren't just following the rules a developer wrote down.
No. They are learning the rules. They're learning from massive amounts of data and from their own experience.
The first big breakthrough examples of this were more about optimization, right? Like DeepMind's AlphaStar.
Exactly. AlphaStar mastering StarCraft 2 at a superhuman level through reinforcement learning. It taught itself how to play better than any human by just playing against itself millions of times.
But our focus today is on the transition from learning to play to learning to create.
And that's where games like AI Dungeon really broke ground. It showed there was a commercial appetite for AI that could adapt and generate text in real time, responding to whatever crazy thing the player typed.
That is crafting a unique adventure just for you.
It proved that content could be emergent, not just curated. And that right there, that ability to go from a fixed script to generating a potentially infinite world on the fly, that leads us straight to the first pillar of this revolution, automating creativity.
Procedural Content Generation, PCG.
Yes, but we need to be really specific here. For anyone listening who's familiar with the term, we have to distinguish modern AI-enhanced PCG from, say, the randomization you'd see in an old roguelite game.
Good point. So let's clarify that. What's the formal definition of PCG, and how does machine learning take it to a whole new level?
At its core, PCG is just the algorithmic creation of game content. So levels, terrain, quests, items, anything that isn't placed by hand.
Historically, that meant pretty simple algorithms. You'd use a seed number, and it would spit out a deterministic result. Place a river here, scatter some trees there.
Right. But when you couple PCG with generative AI, it becomes truly adaptive and scalable. The system starts to understand the semantics of the content. It understands what a forest is.
So instead of just randomly scattering tree models,
It understands that certain trees grow near water, that clearings have a purpose, that the density should change based on the terrain. It understands where a tree should go to make the world feel believable based on what it's learned from real-world data or artistic examples.
it's the difference between random noise and structured, purposeful creation.
Precisely. And our sources point to this powerful triple benefit that this new approach brings to the table, and it fundamentally changes game development.
So benefit number one, the most obvious one for players.
Diversity in gameplay.
Right. If the content is constantly being generated, the terrain is different every time, the enemies are in new places, the puzzles have shifting solutions, then no two play sessions are ever identical.
Which is absolutely critical for two things: replayability and the longevity of live service games.
Because if you can predict the layout of every generated dungeon after 10 hours, you get bored. You stop playing.
But if the rules for generation are themselves adapting, say the AI learns that players are exploiting a certain type of level design, it can stop generating those levels. The game remains surprising, it remains engaging for far, far longer.
Okay, benefit number two is all about the economics. This is the one that gets the green light from the business side.
Efficient resource management. It's huge. Automating all this content creation drastically reduces production time and cost.
So a small indie team can now, using these generative systems, produce a massive, highly varied game world.
A world that 10 years ago would have required a huge studio with an army of artists manually placing every single asset.
It totally changes the scale of what's possible for smaller teams.
And it changes the role of the human developer.
Absolutely. Their role shifts away from that rote manual production and moves toward high-level design, toward curation, toward narrative oversight. The creative director is now specifying the intent of a world, not drawing every single rock in it.
And the third benefit, this one ties right back to that machine learning core. This is personalization. This is where the game starts to learn about you.
This is built on a concept called player modeling. The AI is actively tracking your preferences, your skill level, your favorite weapons, where you fail, how you move.
All that telemetry data that games already collect, but now it's being used in real time. The AI uses that data to dynamically shape the environment or the missions to offer you a tailored experience.
So if I'm a new player, struggling,
The system might gently guide you towards tutorials you've missed, or maybe it just lowers the number of enemies in the next section.
Yeah.
It eases you in.
But if I'm a pro player who's found a way to cheese the system,
The AI sees that. It recognizes you're exploiting a mechanic, and it will rapidly start generating content specifically designed to counter your strategy. It forces you to adapt.
so the game itself is dynamically balancing difficulty, pacing, even the story, based on who I am and how I play.
It's a constant feedback loop designed to maximize your engagement. So, with that framework in mind, let's look at the actual tech, the workhorses that are creating all these assets.
The core generative architectures. Let's start with the one that really brought this stuff into the mainstream a few years ago, GNs, Generative Adversarial Networks.
Right. GNs were a revolution for realistic image generation. And their mechanism is just fascinating. It's intrinsically competitive.
Adversarial.
Exactly. You have two neural networks. The generator creates the content, say, an image of a person's face. And the discriminator tries to determine if that face is a real photograph or if it's a fake generated one.
And they train against each other?
Constantly. It's a loop. The generator gets better at making fakes, which forces the discriminator to get better at spotting them, which in turn forces the generator to get even better.
It's like an art forger and an art critic locked in a room, endlessly trying to outsmart each other.
That's a perfect analogy.
Yeah.
And they do this millions of times until the generator's output is so photorealistic that the discriminator can't tell the difference anymore.
So in gaming, where do they excel?
Primarily visual content, textures, images, style transfer. We see things like StyleGAM being used to generate incredibly high-fidelity, seamless, and varied textures for environments. And tools like Pix2Pix are great for things like character art, taking one pose and transferring it to another while keeping the style consistent.
But the sources we looked at also highlighted a really big limitation with GANs, one that made them less than ideal for creating really diverse worlds.
Yeah, it's a problem called mode collapse.
Mode collapse, what is that?
Because it's a competition, if the generator stumbles upon a few examples that consistently fool the discriminator, it might just stop trying new things. It stops exploring the full diversity of the training data and just starts churning out slight variations of the few things it knows will work.
Oh, so for a game, that would mean it starts generating assets that all look kind of the same?
Repetitive.
Okay.
Derivative, you lose the variety. And that predictability is the #1 enemy of good procedural generation.
And that's where the newer architecture, diffusion models, really started to take over, because they solved that stability problem.
They did. Diffusion models have a completely different approach to creation. It's not competitive, it's more constructive.
How does it work?
The process is sort of inspired by natural processes, like chemical diffusion. You start with a clear, structured piece of data, an image, and the model learns to add random noise to it, step by step, in a very controlled way until it's just pure static.
Okay, so it learns how to destroy an image.
It learns that process perfectly,
Yeah.
and then it's trained to do the exact reverse. It learns how to take that pure noise and step by step, patiently refine it, removing the noise layer by layer until a structured, coherent image emerges.
So creation is an act of refinement, of bringing order out of chaos.
It's a much more stable and gentle process than the constant battle inside a GAN. And because of that, diffusion models tend to have more stable training, fewer convergence issues, and most importantly, they are far less prone to that mode collapse problem.
Which means higher quality and greater variety in the final output.
Exactly. And we're seeing this in really complex areas. For example, a model called Motion Diffuse uses these principles to generate remarkably natural human motion from just a text prompt.
So you could type a person cautiously walking up a flight of stairs, and it generates the animation data.
Yes, and it coordinates all the different body parts and the timing to make it look subtle and believable. That's critical for high-quality animation, where you need that consistency and nuance.
So we have these incredibly sophisticated tools for 2D art, textures, animation, but the holy grail, the ultimate ambition in asset creation, has to be text to 3D modeling.
Oh, absolutely. Taking a sentence and turning it into a usable, game-ready 3D mesh. That's the dream.
And what's the state of play there? How close are we?
Well, the emerging systems are definitely making that conceptual leap. Our sources talk about developers using tools like Leonardo AI to generate amazing concept art. You type in biomechanical chicken creature, and you get this incredible inspirational image. The raw idea is there.
There's a big but.
There's a huge but.
Yeah.
The step from that compelling 2D concept or even a raw 3D output from an AI to a clean, optimized 3D model that you can actually use in a professional engine like Unreal Engine 5, that is still the industry's biggest bottleneck.
Okay, so break that down for us. Why is that transition so difficult? Why can't the AI just spit out a perfect game-ready model?
It really comes down to two major technical hurdles: topology and optimization.
Topology, the structure of the polygons, the mesh itself.
Exactly. When an AI generates a 3D shape, it often creates this disastrously complex and messy polygon structure. The mesh is super dense, it's irregular, and it's just not built for efficiency.
So if I generate a dragon model, it might look great as a static image.
It could look amazing, but the moment you try to animate it or render it in a scene with 100 other assets, your game's performance just tanks. The frame rate plummets because the mesh is too heavy and chaotic for a real-time engine to handle.
So it needs a human to go in and fix it.
It needs extensive human intervention. An artist has to do what's called retopologizing, basically.
Yeah.
Rebuilding the mesh from scratch over the AI's concept to make it clean, efficient, and ready for animation and rendering.
Which means that while the AI is accelerating the concept phase,
The usability phase, for 3D assets at least, still requires a ton of manual labor. And that severely limits the efficiency gains for 3D art pipelines right now. The big wins are still in 2D assets, textures, code, things where the output is much more immediately usable.
that's a really crucial piece of context. It's not quite infinite creation yet. It's more like infinite inspiration that still needs a human sculptor to finish the job.
A very good way to put it.
But let's move past creating single assets and into simulating existence itself. Because here's where it gets, truly mind-bending. Let's talk about world models.
This is the absolute cutting edge. Many researchers are saying that world models are the next major AI modality, the next big step after generative video, like we've seen for models like Sora.
Right, so if a generative video model is essentially 3D, it's space plus time.
Then world models are conceptualized as 4D. They deliver interactive experiences with both temporal and spatial consistency. It's not just a video you watch. It's a world you can step into in effect.
Okay, let's contrast that with the traditional game engine. A normal engine calculates gravity, collisions, physics, all based on millions of lines of hard-coded rules written by programmers. What is a world model doing instead?
A world model learns the rules of physics and the environment's behavior purely from data. It doesn't have a built-in gravity equation. It imagines how a world evolves in response to a player's actions, allowing it to predict the next state of that world in real time.
It learns causality from observation, not from a rulebook.
That's the core of it. And we have this perfect proof of concept to talk about, the tech demo called Descartes' Oasis.
Right, the Minecraft-like generative world.
Yes, released in October of 2024, and its mechanism is what's so groundbreaking. It was trained exclusively on millions of hours of Minecraft gameplay footage.
And that's it, just video.
Just video. It was never given an input that said, if you break a sand block, gravity makes it fall. It learned all of it. The physics, the lighting, how objects behave, even how the inventory system works, solely from watching people play the game.
So it's building a mental model of the rules of the Minecraft universe just by watching.
It is. And it uses a technique called next frame prediction. It's a very fast, very sophisticated form of inference that lets it generate physics-based gameplay in real time. You can move, jump, pick up items, break blocks. And the AI generates the appropriate physical consequence based on its learned understanding.
That's a radical redefinition of what a game engine is. It means the limitations are no longer about a developer's ability to hand code every single rule and exception.
The limitation becomes the AI's ability to learn the dynamics of any simulated reality, as long as it has enough data to watch.
This idea of learning underlying dynamics, of self-organization, it brings us to another equally fascinating approach to simulating living worlds: Neural Cellular Automata, NCAs.
NCAs sound incredibly technical, I know, but the source material is right to point out that they're bio-inspired. The concept is actually very elegant.
So let's make that conceptual leap easy. What are they?
Think of them like biological growth, like how moss spreads on a rock or how an organism regenerates a limb. You have a grid of identical cells, and each cell follows a few very simple local rules.
Local meaning it only communicates with its immediate neighbor.
Exactly. Each cell only knows about the state of the cells right next to it. And yet when you let those simple rules interact across a massive grid, you get these incredible, complex, emergent behaviors.
So the designer just programs the simple local rule set.
And the global complexity, a mountain range, a river system, a branching coral reef, it just emerges naturally without the designer having to program the whole mountain.
And these systems are surprisingly powerful. The source mentions they can actually infer complex physics equations.
That's what's so astonishing. It's a huge conceptual leap. Studies have shown that NCAs can learn update rules that are equivalent to complex physics equations, like the Gray-Scott reaction diffusion equations.
Which govern how patterns form in nature, like animal coats or chemical reactions.
Right. And what this means, in practical terms, is that the NCA isn't just memorizing the patterns it saw in its training data. It's learning the underlying dynamics.
So if you train it on images of erosion,
It doesn't just learn to copy those images. It learns how erosion works. It learns the causal relationship between water, sediment, and gravity, which means it can then generate totally new, completely novel erosion patterns that still look and behave naturally.
that has obvious applications for generating believable, natural-looking terrain that feels like it was shaped by time, not just sculpted by an algorithm.
Yes, they're already being used for that. For sophisticated patterns, for creating terrain that mimics real fluid dynamics. The historical challenge, though, was always scale.
They're stuck on small grids.
Right. NCAs were usually confined to these small, low-resolution grids because propagating the information was computationally expensive. You couldn't generate a full, high-definition game world.
But that's changing.
It was a huge limitation until very recently. New architectures are now pairing NCAs with something called an implicit decoder.
How does that work?
The NCA still does its complex evolution on a coarse, efficient grid. But the implicit decoder acts like a high-resolution lens. It takes the abstract data from the NCA and renders it into full HD output in real time.
So you could have a cliff face dynamically eroding in front of you in high definition.
Exactly. It overcomes those previous computational limits, and it makes these powerful self-organizing systems truly viable for creating massive, high-detailed game worlds.
Incredible. So we've generated the assets, we've built the living, learning world itself. Now we need to populate it. We need inhabitants.
And this is where the player feels the impact most directly. This is about building intelligent interactions.
Let's talk about NPCs and the narratives that connect them. We're seeing the rise of what are being called generative agents.
Which means NPCs are finally moving past those old behavior trees, those millions of hand-authored decision branches. They're moving toward complex, human-like decision-making.
And the engine for that is large language models, LLMs.
It is. The mechanism couples an LLM with a sophisticated narrative engine. And this engine is constantly tracking things. The NPC's memory, what's happening in the game right now, its predefined personality, its relationship status with the player.
And it uses all of that context to generate its dialogue and decisions.
So it's not just pulling a pre-written line from a list of options. It's crafting a response that is deeply aware of the current situation.
And the fidelity of these agents, how well they can mimic humans is, well, it's getting concerningly high. There's that one study on simulating human behavior.
Yeah, it was a landmark piece of research. The architecture used these generative agents to simulate 1,000 real people. And here's the crucial part. Each agent's LLM was customized with an in-depth interview transcript from the actual person they were simulating.
So it knew their history, their preferences, their worldview.
All of it. And when they tested these AI agents against major social science surveys, the agents replicated the human responses with 85% accuracy.
And to be clear, that's 85% as accurate as the original humans were when they retook the same survey 2 weeks later.
Exactly. That's the gold standard. People aren't even 100% consistent with themselves. So that 85% fidelity suggests these systems are modeling something very close to generalized human decision-making. They're not just parroting keywords.
And that level of accuracy is what you need to create game characters that feel consistent, that feel emotionally resonant, and that can adapt to whatever wild things players do without breaking immersion.
And this tech is moving out of the lab and into commercial tools very, very quickly.
Like in World AI.
In-world AI is a prime example. They're creating these real-time interactive NPCs that can do vocal responses, they have memory, they have emotional states that adapt, they even integrate with player voice recognition.
You can just talk to them.
You just talk to them. The line between role-playing and just having a conversation gets very blurry. And you see major publishers like NetEase using fine-tuned LLMs in their games to allow NPCs to not only respond coherently, but to actually remember past interactions.
Which creates those genuinely emergent story moments that feel unique to your playthrough.
Your story. The static, repeating dialogue NPC is truly on its way out. But that creates a massive new challenge.
Evolving storytelling while maintaining narrative coherence.
Yes. Dynamic narratives are the big promise here, right? Storylines that are co-created by you and the AI. But the big problem right now is coherence, especially over a long 50-hour game.
Because LLMs are known to have issues with long-term memory.
Exactly. They can struggle with consistent causal reasoning. If the AI is just constantly generating new plot points on the fly, it can very easily create a story that's logically inconsistent. A character hates you one minute and is your best friend the next, with no logical reason for the change.
And it can just shatter your immersion. So what's being done to fix that?
A lot of the research is focused on memory enhancement. There are systems being developed, like LLM, that try to build a human-inspired episodic memory into the LLM, giving it a much longer, effectively infinite context window to recall past events.
And the other paths?
Strict logic modeling. Controlled generation, basically building guardrails that force the AI to check its proposed narrative, beat against a logic model before it says it out loud. Does this action make sense for this character, given everything that's happened before?
And you also need tools that let human authors keep control of the story's overall theme and tone, even if the AI is filling in the details.
That is critical. And that's where systems like What Else come into play. It's a tool designed to help authors shape the narrative space.
So the author provides a high-level outline, like, in this chapter, the player must learn a hard lesson about betrayal.
Right, and the system translates that abstract goal into concrete narrative moments, but it ensures that all the AI-generated variations still serve that core authorial intent. The human provides the why, and the AI provides the how. It's co-creation.
This adaptive approach, it's not just about conversation, it's about mechanics. The sources highlighted some amazing case studies of adaptive gameplay.
Yes, how the AI changes the challenge itself. Let's start with adaptive enemies. In a game called Halo, Origins, the Covenant forces don't just get more health on harder difficulty.
No, the AI is watching you.
It's analyzing your combat data, your preferred weapons, your movement patterns. If it notices you rely way too much on a short-range shotgun,
It changes its strategy.
it adaptively develops ranged countertactics. It'll start deploying shielded units to keep you at a distance. It actively tries to defeat your strategy, not just your health bar.
You can't just find a cheese strategy and repeat it, because the system is designed to learn your cheese and counter it.
Exactly. Then you have something like environmental manipulation, which is incredibly effective in horror games. A title called First Cry. Regenesis uses AI to alter the world based on the player's psychological profile.
How does it figure that out?
It infers it from your performance data, how much you hesitate, your panic movements, where you failed before, and it uses that to personalize the horror. It might turn a place you thought was safe into a trap, or place a jump scare exactly where it knows your anxiety is highest.
The environment itself becomes your personal antagonist.
It does. And you can apply this to moral systems, too, in Dishonored. Shadows of Dunwall, the AI runs a whole city simulation. It tracks how many citizens you harm, combat or not.
A harm metric.
Right. And if that metric gets too high, the simulation triggers consequences. New, more aggressive enemy types start appearing. Society starts to break down. Your actions have a visible, evolving impact on the world.
And the last one, this concept of real-time expansion.
Yeah, a fantasy strategy game called Dark Forest, Eternal Rift. It uses AI to generate and expand dungeons underneath your kingdom in real time.
So as you're building up your city on the surface,
The threat below is dynamically growing in complexity and size, paced against your progress. It forces you to constantly adapt your strategy between building and defending. The game never lets you get completely comfortable. It's always evolving.
which leads us perfectly into the business side of all this, because all this complexity, all this dynamic generation, it sounds computationally expensive. So how is this technology actually making game development more efficient?
The efficiency gains are massive, but they often come from automating the most repetitive parts of the development pipeline. We're seeing a whole suite of AI-assisted tools that are democratizing game creation.
Let's talk about one of those, Ludo.ai. What does that platform do?
Ludo.ai automates that very early, very crucial, and often very time-consuming stage of ideation and market research.
So before, a studio would spend months analyzing trends, brainstorming.
And Ludo.ai does that in seconds. It suggests data-backed game concepts, it can identify underserved beaches in the market, and it can immediately generate matching assets to help you visualize it. Sprites, marketing copy, placeholder videos.
So for a small indie team, that's invaluable. You can kick the tires on a dozen ideas before you commit any serious resources.
It drastically lowers the barrier to entry by taking out a lot of that initial guesswork. And the gains are even clearer in the day-to-day coding pipeline.
Code acceleration tools, the big one being GitHub Copilot.
Right. These tools give you context-aware suggestions. They can generate all the basic boilerplate code for you, and they can help you fix bugs faster. This is especially useful in C# pipelines for engines like Unity.
It frees up the developer from the grunt work.
Exactly. They can stop looking up basic syntax in the documentation and focus their brain power on the complex, unique logic that actually makes their games special.
And beyond creation, AI is also revolutionizing one of the most tedious and expensive parts of development, QA, quality assurance.
QA is fundamentally changing. Instead of relying only on human testers playing through scripted scenarios over and over,
You can have AI do it.
you can use machine learning models trained on huge data sets of crash reports and bug patterns. And you can unleash reinforcement learning agents to just play the game. They can simulate thousands of different playstyles and explore millions of configurations way faster than a human team ever could.
And they're intentionally trying to break things.
They're designed to find those bizarre edge cases, those rare bugs that only show up if you jump in a specific corner while carrying a specific item after 100 hours of play. They find those vulnerabilities much, much faster.
Okay, but the ultimate business impact, the real bottom line number, seems to come from player retention. Personalization isn't just a cool feature, it directly translates to keeping players engaged longer.
This is the highest value proposition for any live service game. Studios feed these machine learning models just petabytes of gameplay data, and the models learn to predict player preferences with startling accuracy.
How accurate?
Over 85% accuracy in predicting what you'll enjoy, when you're likely to get bored and quit, or even what cosmetic items you might be interested in buying.
85%. That's a powerful crystal ball. And how does that translate into retention?
It translates directly into money. The data shows that personalized games, the ones that use those predictions to dynamically adjust difficulty, rewards, and content, they demonstrate 30 to 50% higher player retention rates than static games.
30 to 50%, that's huge.
In the live service market, where acquiring new customers is so expensive, increasing the time every player sticks around by that much, it fundamentally changes the economic viability of your whole project. It's a game changer.
And those are the kinds of numbers that drive massive investment. But with any technological leap this big, we have to talk about the human cost, the ethical challenges. This power comes with some very significant risks.
It's a discussion we have to have, because the tech is moving much faster than the professional and ethical guardrails around it. The latest Game Developers Conference survey found that 30% of developers believe generative AI is having a net negative impact on the industry.
30%. That's a huge number of the people actually building this stuff who have serious reservations. What are their main concerns?
It's a complex mix. There are huge legal worries around intellectual property theft, using copyrighted art in training data without permission. There's the environmental cost, the sheer amount of energy it takes to train these massive models.
And concerns about quality.
A big one, a fear that we'll see a decrease in overall creative quality from rushed, soulless AI outputs. And, of course, the risk of biases in the training data leading to unfair or unrepresentative game worlds.
Let's focus on that quality issue, this idea of creative dependency, the fear that we become too reliant on the easy button.
Exactly. AI content is fast, but it often lacks that deep emotional nuance, that thematic consistency you need for a truly great immersive story. If a studio leans too hard on AI and the output just isn't good enough,
It creates a huge brand risk. Players can tell when something feels generic or auto-generated.
they can't. And then the studio ends up having to spend just as much time and money on human artists to go in and review and fix all the AI's mistakes. You generate 1,000 assets in a minute, but if you have to spend an hour correcting half of them, you've negated a lot of that efficiency gain.
So this forces the industry toward what's being called the human-in-the-loop model?
It's the only realistic path forward. The consensus is that the future has to be hybrid systems. AI generates content at scale, but human creativity must strictly guide and curate that content.
So the human role shifts from being the manual laborer, drawing every leaf, writing every line of dialogue, to being the creative director.
The strategic partner. You're
Yeah.
focused on guiding the AI, on maintaining the tone, the authenticity, the soul of the project. That becomes the strategic imperative for studios. Preserve that creative oversight. If you automate the heart of your game, you risk losing your audience.
Okay, let's talk about another distinct challenge. Monetization. How do you sell a game that is dynamic, individualized, and potentially infinite? The old buy it once for $60 model doesn't really fit.
It's fundamentally incompatible. That static purchase model just breaks down. So experts have considered subscriptions, but there's a big hurdle there.
The uncertainty.
Right. Why would I subscribe to a game when I have no idea what value the dynamically generated world will deliver next month? I might hate what the AI comes up with.
It's a fair point. You're asking me to commit to a product that is constantly changing in unpredictable ways. So how do you align the uncertainty of the content with the certainty of a transaction?
This led to a really interesting novel approach being suggested: pay to alter.
Pay to alter. Okay, let's explore that. How would it work?
The core idea is simple. If the AI generates something you, the player, dislike, a quest feels boring, a character's annoying, a plot point just doesn't land for you, you can pay a small microtransaction to immediately change or re-roll that element.
So the payment is tied directly to my dissatisfaction and my desire for control.
It's brilliant because it acknowledges the inherent unpredictability of the AI while giving the player a sense of agency over their personal experience. The cost is justified by the instant satisfaction of correcting the AI's mistake.
It aligns monetization directly with player happiness, but I can see a risk there, a potential dark pattern.
A huge risk that needs critical oversight. Could a studio be tempted to intentionally generate slightly frustrating or suboptimal content, knowing that players will be more incentivized to pay to fix it?
If the base experience is intentionally annoying, the model becomes coercive, not convenient.
It's a critical ethical line. The design has to ensure the core, non-paid experience is still high quality, and the alteration is a premium convenience, not a required fix.
And that ties into the broader issues of governance and ethics. With these systems collecting so much behavioral data on us to personalize the experience, transparency becomes non-negotiable.
Studios have to be clear. They need to disclose how AI decisions are influencing your gameplay. If the game is actively manipulating the horror based on your psychological profile, you need to know that data is being used, and you need to be able to opt out.
You need a clear, auditable process.
You need transparency, accountability, and clear authorship. Without those guardrails, studios risk a complete erosion of player trust. And in this market, trust is everything.
This has been an incredibly comprehensive look at the foundations of what's coming. We've covered the efficiency gains from GANs and diffusion models creating assets, to how neural cellular automata can build self-organizing worlds, and how generative agents are turning NPCs into thinking, evolving characters.
And it's clear the path forward is a balance. It's about harnessing the enormous benefits of AI, the efficiency, the personalization, while maintaining that critical, non-negotiable human oversight and building strong ethical guardrails.
So the big takeaway seems clear. AI is creating games that are no longer static products you buy in a box and consume once.
They're becoming living, adaptive worlds. Worlds that are, in effect, being co-created in real time by the human player and the machine.
So what does this all mean for the people who dedicate their lives to making these worlds? If AI systems become capable of generating complex, responsive game worlds on demand, if they can fundamentally change the game from a finite product to an infinite game of perpetual evolution, what becomes the ultimate measure of success for a game designer? Is it the quality of the final content they ship on day one? Or is it the elegance and robustness of the generative rules they create, the rules that allow that game to evolve forever?
That's the question they're all wrestling with.
And that's something for you to mull over as the infinite game continues to evolve.